Fantastic. I think people are coming in. Allison is going to be accepting everybody as they log in, but I think we can get started. Hopefully, everything works. If anything happens, my colleague will let me know. So, welcome everybody. I'm super happy to be here with you. It's a little different doing a webinar because I don't see anyone's faces, but hopefully you'll enjoy today's presentation. If you've never been to one of our webinars or you have never seen a presentation that I've done, I really looking forward to it, and hopefully I bring some good quality information that is going to be useful for you and for projects that are coming up that you may be working on. A couple of notes that I need to share with you first and foremost. This presentation is valid for 1 hour educational credit with the AIBC, AAA, and OAA. And you'll be receiving your certificates within 24 to 48 working hours after the presentation happens. So it'll all be done automatically. Don't worry, it'll be sent straight to your email. Another little note is that if you have any questions, please type your questions down in the Q&A section of the presentation. Not the chat, it has to be inside the Q&A, please. If we're able to respond to those questions as we go through the presentation or at the very end, we will definitely do so. But otherwise, we'll make sure to reach out to you individually and answer those questions at another time, hopefully within 24 to 48 hours as well via email. So without any further ado, I'd love to introduce myself. So my name is Christian Wallace, and I work in sales specification with Acoustics and have been doing so for about 9 years now. My goal is to help our clients avoid noise-related issues with smart and effective solutions. Today's objectives are going to be pretty simple. One, we're going to define general acoustic principles of acoustics. Then we're going to understand how noise travels through different types of structures. Then we're going to explore solutions to reduce noise transfer in floor ceiling assemblies. And we're going to recognize the differences between wet and dry toppings and their benefits. And we're going to discuss durability and budget impacts as well. So without further ado, let's get this going. Perfect. So a little introduction about our company, guys. So Acoustitech is a broker that specializes in acoustic solutions. And we have been in this industry for about 25 years. And Acoustitech is not just an acoustic solutions provider, like I said. We are a broker, and really our mission is very simple. It's providing the right product at the right place. And this through our specialized ecosystem that I'm going to talk about in the next slide. So basically, we work with a network of industry leaders. So Acoustitech being at the center of it all, this is what our ecosystem looks like. So we work with amazing companies like Suprema, for example. Suprema specializes in acoustic solutions that are great for wood construction, as an example. Now, you may know Suprema for their waterproofing and roofing systems. However, they have an acoustics division that Acoustitech handles. And their solutions are absolutely fantastic for anything that's related to light wood frame structures as well as mass timber structures. Then we have another company called Fermacell. I'm going to try to bring a pointer if I can right here. There we go. Excellent. So we have another company called Fermacell, who is a great partner of ours, and it's part of our ecosystem. This is a company that is based in Germany. and they specialize in alternatives to wet topping solutions, which we're going to talk about a little bit later. But they provide solutions that are going to replace wet topping solutions in wood construction, whether it's mass timber construction as well as light wood frame, where often we see gypcrete and concrete toppings being used. Another one of our partners is Rothoblast. Rothoblast is absolutely fantastic when it comes to mass timber. They have a great selection of acoustical products, and they also go quite large in terms of mass timber. They actually have and manufacture connections, screws, fasteners for anything related to mass timber, and much, much more. Pack International, a company based out of Portland, Oregon, they specialize in clips, acoustical clips. They have over 100 different types of variations of clips that can be used in floor systems, ceiling systems, as well as in walls. And this to make sure that we achieve the acoustical ratings that are set for any given project. Artopex is another partner of ours. They create these awesome mute boxes, so literally small pods where you can have a super intimate meeting that is not going to be disturbed by any noise. So really a noise canceling, think about it that way, box where you can work by yourself or you can have a meeting that is kind of private. And then Acoustic as well being part of our ecosystem with the acoustic solutions that we manufacture, because we're also manufacturers of products and we specialize in the flooring section. And we've developed an awesome expertise in that particular area, exploring a lot of different types of flooring and how different types of floor can affect your acoustic performance. Now, I wanted to talk a little bit about our collaborative approach, and it's all about understanding the goals of the client. So these are all the building professionals that we're going to have a conversation with on a day-to-day basis. Developers, builders, architects, acoustical engineers, structural engineers, general contractors, as well as installers. And really here, the focus is to make communication easy between all these building professionals. That's really where Acoustic comes in with a great expertise and knowledge about acoustics, but also with one goal set in mind, which is making communication and conversations about acoustics flow much, much better. And we obviously support each persona so that decisions about acoustics are simple, because sometimes it can be a little bit complex. Acoustical engineers are going to set their specific ratings that they're planning to achieve in a certain building. Architects are going to have their design in mind. Installers and GCs and builders are going to have their own idea of how to do things, and sometimes it can be complicated. So our goal is really to come in here and make all that flow much, much easier. So here, all we wanted to mention is that we come from a world of floor ceiling assemblies. And really, we have become over the years a specialist in this particular assembly of floor ceilings. We have over 400 different products that we can bring to the table with our partners. Obviously, I'm not going to talk about those today because we don't have 5 hours together, but just know that anytime we're going to be assisting in a project, we're going to be going to all of these resources that we have to bring the best product for your project, whether it be because you're focused on performance, maybe you're focused on budget, or maybe you're focused on speed, as an example. So all these different things we take into consideration. Now, through the years, we've been able to collaborate in many projects. We have over 800 projects that have been completed in Canada as well as in the US. I personally, and I didn't mention this at the beginning, I take care of Toronto as a territory. I live in Toronto, but I also take care of New York and Florida. But our team entirely, we cover the entire Canada and the entire US, and we're able to assist with projects. So last but not least, one thing that makes us very, very powerful in this area of acoustics is the data that we have. We have over 3,000 acoustic tests in our database, meaning that we would go to those tests anytime that we're making a recommendation, so that this is based off of actual data and actual tests that we have done. And this is a combination of laboratory testing at Intertech as an example, or the CNRC in Ottawa, as well as many, many, many tests in the field. And when I say in the field, I'm talking about real life projects. The acoustic challenges that we can help with and we can guide you in are going to be the following. So floors, ceilings, walls, gyms, stairs. I don't need to read them all, but you can see that we can cover a lot, including mechanical rooms, drainage pipes. Nobody likes to hear their neighbors flushing and things like that. Flanking noises, impact noises, mechanical noise, airborne noise, and more. So now I think it's time to talk about acoustic code requirements. So first of all, we're going to start talking about airborne noises. So what are some examples of airborne noises? These are going to be noises that are going to travel through the air. And it can be anything like music, television, dog barking, for example. And these are going to be measured with a rating that we call STC. STC stands for Sound Transmission Class. And in Canada, if the audience here is from Canada, you must know that building code in Canada has a requirement for STC. And that requirement is an STC of 50. Okay, that is the minimum rating that is required for multifamily residential buildings. That is in building code. Now, there's also going to be another rating called ASTC, and I want to explain really quickly the difference between both. So STC is a laboratory test, meaning that it was tested in a lab with a controlled environment, perhaps where there's no windows, there's no doors, and where we're measuring only the direct path of how sound is traveling, as an example of how that sound is traveling directly from a floor ceiling assembly or between two units in the wall assembly. So that direct path of how that sound is traveling. And basically, the higher the number, the more comfortable your sound becomes. So the more sound is being absorbed by either your floor ceiling assembly or your wall assembly. And this image right here basically is showing you how we perform a test to measure airborne noises. So in one unit, you're going to have a speaker that is going to create a very loud noise. And in another unit, you're going to have a microphone that is going to pick up on those noises and then provide us with a lot of data that then we can calculate to get an STC rating. So as an example, if you're wanting to measure how a wall assembly is going to perform, you're going to have a speaker in one unit and a microphone in the other. You're going to create that noise for a certain amount of time, and then you're going to measure just how much sound is being absorbed by that wall assembly. Okay? Now, when it comes to the floor ceiling assembly, the same thing goes. You're going to have a sound source, so a speaker, a microphone then, and you're going to create that noise, and then the microphone is going to pick up on that noises and then provide us with data that is going to determine how much sound is being absorbed by the floor ceiling assembly. Now, one thing that is very important to know, STC means that it was tested in a laboratory, and ASTC means it was tested in the field. Now, when I say field, it means that it was tested in an actual live building that exists. Now, building code, because when you're testing in the field, there's a lot of alternative ways of how that sound can travel, right? You're in an actual building where there's windows, there's doors, there's electricity, there's electrical outlets, there's plumbing, there's air vents. Because of that, they're considering that there's a lot more areas where sound can travel, meaning that they're going to accept a decrease in performance of about 3 points. Meaning that if you were to test in a field and you were to obtain an ASTC of 47, it would still be deemed code compliant because they allow for a 3-point decrease. Okay, so a lot of technical information, but just remember, very simple. STC is a laboratory test. Building code requires an STC of 50. ASTC stands for Apparent Sound Transmission Class, and it's a test that is done in the field. And building code accepts a 3-point decrease because there's a lot more areas where sound is traveling because flanking is measured. A little bit more on flanking later on. Now, when it comes to impact, impact is anything that travels through the structure and objects. It can be walking, running, moving furniture, dropping something on the floor. These are all considered impact noises. And they're going to be measured with what we call an IIC rating, which stands for Impact Insulation Class. Now, same thing goes for IIC and AIIC. IIC is a laboratory test in a controlled environment in a laboratory like Intertech, and AIIC is going to be a field measurement in an actual building. Now, one thing that is very, very important to know, building code in Canada does not have a requirement for IIC. They simply have a minimum recommendation of IIC 55. However, in the US, it is a requirement. They have a requirement of IIC 50, which is the same for STC, STC 50. Now, the reason why I'm saying that this is very important to know, and it's unfortunate that Canada doesn't have IIC as a requirement, is because 80% plus of complaints that we hear about are related to impact noises. If any of you in the audience here have ever lived in a condo building, you probably know or remember that most of the noises that you're going to hear is going to be impact noises. Hearing your upstairs neighbors walking around, hearing their kids running around, hearing them moving furniture at 3 a.m. And these are all related to impact noises. So here's what I'm trying to share with you is although impact noises are not a requirement, they're extremely important and should not be neglected. So we always recommend to design and build to the recommended minimum of IIC 55. And this is extremely important, especially if you're designing a building that is made for or that is being advertised as a higher end product. If you're advertising a luxury condo type building where people are paying significant amount of money for their condo, if they move in and they start hearing their upstairs neighbor, just believe me, they're going to pick up the phone and call somebody to complain because they don't know anything about building code and quite frankly, they don't care. They're going to pick up the phone and complain to the builder or whomever it is that was responsible for that decision because paying a substantial amount of money for a unit comes with expectations. And this is where we hear horror stories, guys. Hearing about builders getting sued, hearing about builders having to go back in, remove all the owners, having to replace entire floors or replace entire ceilings and start all over again because exactly this happened. Impact was neglected because it was not in the building code necessarily, but they were able to put a lawsuit on the builder and have this changed because it didn't meet their requirements. So just remember, IIC, like I said before, tested in a lab, AIIC tested in the field because flanking is measured, okay? This image right here is just showing you how we perform a test for impact noises. So you're going to have a tapping machine with a bunch of hammers underneath, and then you're going to have a microphone below that is going to measure those impact noises that that tapping machine is creating, and then we're going to get a rating for IIC. So here I want you to notice, we're not just testing a single product, we're testing the entire floor ceiling assembly, which takes me to my next slide, which is field versus laboratory testing. Now, what I'd like to mention here is the following. Acoustic solutions, especially underlayments in this example that I'm going to give you, have been portrayed in the marketplace with a lot of different ratings and can become very, very confusing. And here's what I'm trying to say. Sometimes you're going to evaluate an acoustical underlayment that shares with you a technical data sheet that has a very high number, right? Oftentimes, when I present an underlayment to a client, their question is going to be, well, Christian, what's the rating on the product? And although that's a very good question, it's a question that has many, many possible answers because it all depends where you're using that underlayment and how it's being tested, right? So let me give you an example. We actually put to the test the exact same floor and the exact same underlayment, but in two different types of buildups. So if you take a look at the left side, you're going to see a 8-inch concrete slab on its own, no suspended ceiling. Normally, this is what we see in a typical high-rise building, right? It doesn't have a suspended drop ceiling, or at least in the most areas, that is not going to be included. It probably has some drywall attached to the underside, but that's it. So an 8-inch concrete slab by itself with an underlayment and a flooring is going to perform at an impact rating about AIIC 56. Now we're showing this because this was tested in the field, right? That's why you see an AIIC result. Now we took the exact same floated floor, which in this case was a laminate floor, with the exact same underlayment, but tested it over an 8-inch concrete slab that has a suspended drop ceiling, and the performance increased to AIIC 72, which gives us about a 16-point difference, right? So here's where I'm trying to get to. If you're evaluating an underlayment and you see that there's a very high number, and by very high, I'm talking anything over 65 impact, chances are that there is a suspended ceiling. However, unfortunately, a lot of acoustic underlayment companies are not going to advertise and share with you how they tested their solution. And this is, for the most part, related to more inexpensive type underlayment. So if you see a product that has a very high rating, the most important thing to find out is how that product was tested. Because if it was not tested in a way that resembles your building, it means that you may get a completely different result. So taking a look at this image right here, let's say you were advertised or shared with an underlayment that says IIIC 72 on a technical data sheet, but it doesn't give you any information of how it was tested. To you, that looks incredible, right? Because if you remember, building code recommendation is IIC 55. If you have a product that shows you a 72, to you, that's an amazing product that is going to behave very, very well. However, if you install that product that was tested with a suspended ceiling and use it in a building that doesn't have a suspended ceiling, you very well may be much lower than you expect it to be at an AIC of 56 and maybe even lower, right? So, to summarize this, just try to find out how the product that you're evaluating was tested. And if it's not you that is doing that job, an acoustic consultant can come in and evaluate that for you as well. But that's also where we come in and bring a lot of clarity and transparency to everything that we're sharing. So just remember, the rating doesn't come from a single product, right? I cannot identify a single product for it having a specific rating because it all depends how it's being tested. One product can behave one way in a concrete building, but it can behave completely different in a light wood frame building or completely different in a mass timber building. So just remember, testing and results come from an entire assembly. It doesn't come from a single product. So here, what I wanted to do, guys, is just share with you an AIIC on-site testing that we did a few years ago. So you can take a look at how a tapping machine looks like, how it operates on this short little video. So I'm going to go ahead and play that right now.
OK. Attendez-moi ça.
There we go. So as you could see, that's the tapping machine, has a bunch of hammers underneath, creates a significant amount of impact noise to the surface of the floor. We have different areas where we're going to place this tapping machine. The same thing with a microphone below, a couple of different settings. We get all that data, all that information, and then provide what we call an AIIC result, because here we were actually inside of a real building. And as you could see, we were not just testing an underlayment, we were testing the floor, we were testing the underlayment, as well as the structure all together. And that microphone that you saw right there, believe it or not, it's something that is very expensive. It can cost upwards to $20,000. So very, very fine piece of equipment that I don't dare touch because I don't want to break. So yeah, pretty cool. Hope you appreciated that. Now, I wanted to set the table with a couple of exercises here. Let me see if I can take the pointer off. How can I do this? Pointer. There we go. Excellent. So I wanted to set the table with a little exercise, and I wanted to share with you a couple of different sounds. But before we do that, I wanted to share with you something that is very important to know. When we're evaluating materials and we're analyzing structures, just know that each building has its own different type of frequency, right? So a concrete building by nature is going to have a lot more mass, it's going to have a lot more weight, and by nature, its biggest enemy is high frequency noises. So, very high pitched noises. If you've ever been to a concrete building and dropped your keys on the floor, you've noticed a very high pitched noise. Those are high frequency noises. So, we need to select the materials that are best suited to control high frequency noises. Then you're going to have buildings like lightwood frame or mass timber that are very prone to low frequency noises, which are bass sounds. So, you know, when you walk in a wood building, you're going to have very boom, boom, hollow type noises. Those are low frequency noises. And you're going to have to work most likely with very different materials in order to tackle those low frequency noises. So, do not think that because one product worked very well in your concrete building, that it's going to behave the same in your wood building. We have to work with different products because we're having to deal with different frequencies and different issues. Now, with that out of the way, I wanted to share with you a little exercise here just to see how good your hearing is. But, little disclaimer first. If you have headphones on or AirPods on, please lower your volume, okay? Listen to me. Please lower your volume because this exercise involves very high-pitched noises, and the very first one is extremely loud. And if you have your volume set on the highest level, you're not going to like me very much, okay? So this is just to see how good your hearing is, and I think it's just a little cool exercise. So again, for those with headphones, turn your volume down and then readjust. But the very first one, I'm just going to play for a second or two, okay? So 1, 2, 3. So very high pitched noise. Okay. Everybody normally should be able to hear this type of frequency. Now, if we have people in the audience that are under 50 years of age, they should be able to hear this second one. Again, just a few seconds. How did you do? I would have loved to be in front of you so you can tell me who could hear it, who could not. But on the third one, we may start losing some people. Okay. So if you're under 40 years old, you may not be able to hear this. So I'm going to play it right now. Now, I'd like to remind you, it's not the little crackling noise at the beginning. It's actually the beep sound that comes right after. I'm going to play it again. There you go. How did you do? Maybe everybody got it. And if you did, that's awesome. However, I'm going to be very surprised if anybody gets the last one. Maybe you have some very young people in the crowd here today. So if you can get this one, congratulations. I'm going to play this in 1, 2, 3. I'm going to try to play that again. There you go. So if anybody was able to get this, my hat's off to you because I cannot get this. Even when I was under 30 and I was with Acoustics, I could have never gotten this number. So if you did, fantastic. And here, just know there's no medical background whatsoever. It doesn't mean that if you couldn't hear it, that there's an issue with your hearing. It just means maybe you went to too many loud concerts, too many Metallica concerts or something like that. I'm just joking. But basically here, it's just to show you that everybody's hearing is going to be different. Mm. And sometimes what happens is that some people that are used to living in a single family home all of a sudden move to a condo building and they may be very bothered about all the noise that is happening inside of the building, but it doesn't mean necessarily that the building perhaps wasn't designed the way it was supposed to. Sometimes it just means that they're not used to hearing all these noises and living with other people, right? Because there's no such thing as completely soundproof. It's not like we're creating a noise canceling chamber, right? What we're trying to create is an environment where any noise that happens becomes more and more comfortable. Now, let's talk about basic acoustic principles. And here we go. We're going to have 5 different acoustic principles, guys, not 5 like this. Yes. So basically, these are going to be very simple principles that can make a huge difference in a project. And I'm going to try to simplify this. And that's why we have these little videos, animations, so you can get a sense of what I'm trying to explain, to be clear. So the very first example is going to talk about mass. Excuse me. What we're trying to show here is 2 balls. The balls are going to represent an airborne sound. Think about it like music, loud music, okay? And on each side, we're going to have a wall. Each wall represents a different type of structure. On the left side, you're going to have a concrete structure. But on the right side, you're going to have a wood frame structure. And what we're trying to illustrate here is the heavier and the more mass you have in your building, the less air sounds are going to go through. So as you can see here, the wall barely moves and it doesn't crumble. However, in a light wood frame structure or a mass timber structure where it's significantly lighter, it doesn't have as much mass and as much weight, air sounds are going to go through much easier. And as you can see here, the sound goes completely through and actually brings the wall down. That's what we're trying to explain. Just remember, the way you control airborne sounds is with the mass and the weight of your structure. That's why oftentimes people like working with concrete, because they say, hey, it's a concrete building, it's going to be great for acoustics. And they're right to an extent, because concrete buildings are already going to be code compliant on their own. An 8-inch concrete slab by itself is already going to be achieving STC 55 on its own on average. No need to add a suspended ceiling, no need to add a flooring or an underlayment. It's already going to be code compliant on its own. However, for impact, walking, running, and things like that, an 8-inch concrete slab on its own, it's not going to do a good job. As a matter of fact, an 8-inch concrete slab on its own is going to perform around IIC 30 to 32, which is nowhere near the recommended 55 IIC. Okay, now to the second principle, which is flanking. Basically, flanking means all the alternative ways of how sound and vibration can travel. And you can see in this example right here on the left side how flanking can affect your building. Think about the ball being an impact noise, right? Like a footfall, or literally like dropping a bowling ball on the floor. You're going to see that if you're not separating materials effectively, as in this case, you're going to have a demising wall sitting on top of your concrete topping that is continuous. You're going to have that impact happening in one unit, but everything is going to vibrate. Everything is going to move, meaning that energy is being transferred to the unit on the side, completely disturbing the next door neighbor, right? However, if you're separating properly, you're going to have that demising wall going all the way down, and then your concrete topping really separated by units. You're going to have that impact happening to the surface of the floor, but the vibration is not being transferred as much to the unit beside it, effectively controlling your flanking. So it takes me to the next principle, which is very simple, which is decoupling. So the way you control impact noises is by decoupling materials. Decoupling meaning separating hard materials with some sort of a resilient absorbing material. So here you're going to have three balls. Think of these three balls as them being an impact noise. On the first example, you're going to have a ball hitting the surface of the floor, which is a wood structure on its own. Excuse me. I'm speaking way too loud. So the second example, what we did is we have a light wood frame structure with a wet topping over top to help for acoustics, right? Often, if any of you have worked in a wood building, you're very familiar with the concept of using a gypcrete or a concrete topping to help for acoustics, maybe sometimes for fire, but mainly for acoustics. Now, if you remember what I explained before, if you're adding mass, you're adding weight to your building by adding that wet topping, you're effectively going to add mass and weight, so you're going to help your airborne sound control. However, for impact, it's not really going to change much. As you can see, the ball is going to come to the surface of the floor and it's not going to bounce much, meaning that that vibration is being transferred to the unit below very quickly. Now, what you should be doing is separating your wet topping from your concrete, so from your wood frame structure with some sort of a resilient material that is going to absorb that vibration and that energy, therefore not transferring it to the unit below. As you can see here, the ball touches the surface of the floor and it bounces, meaning that that resilient material is absorbing all that vibration and energy. Now, for the third principle, called sealing. This is very simple, guys. It just means that wherever air can go through, sound can go through as well. Let me give you an example. If you've ever been to a hotel where normally acoustics are actually pretty good, but if there's a little bit of space underneath the door where air can come through, you're going to be able to hear everything that's happening outside in the corridors. People coming back from a night out at 3 a.m., having a conversation, anybody coming through and walking through, that corridor. Because of that little bit of space underneath your door, all the sounds are going to come in. So just think that these little details can make a huge difference at the end of the day. And last but not least, it's void treatment. And this is really related to cavity spaces. It's extremely important that within cavity spaces, you have planned to fill those up with some sort of batt or blown insulation. And that's where these little red strings come into play. It's just showing you how batt or blown insulation can effectively slow down airborne noises, right? It slows them down dramatically, making it so that they don't transfer to the next unit. However, if your cavity is left empty, that sound is going to go through very quickly. And as a matter of fact, if you leave a cavity space empty, it's going to create what we call a drum effect, meaning that it's going to amplify any noise that is coming through. Now, a little bit more on flanking because this is a very, very important thing to grasp. It's one of the easiest things to control, and it's one of the things that could make a huge difference inside of your project. So, again, what is flanking transmission? So flanking transmission is when sound travels indirectly between spaces, right? So sound can travel directly from one unit to the other, but they can also travel, as an example, through the ceiling or through ductwork. They can travel through the slab as well. And all these different areas are considered flanking paths, okay? Same as this example here with this light wood frame structure. You can have a direct path of how that impact sound is traveling from one unit to the other, but that same vibration can also travel within the floor and the joist. It can travel down and through the walls. So these are all the areas where that sound can travel. So this is why it's very important to work with a couple of different materials in order to prevent all that flanking from happening and getting a better acoustic result. So takes me to my next slide, which is propagation of sound in different structures. And we're going to start off talking about concrete because a lot of people are working with concrete buildings, whether it's commercial, institutional, hospitality, residential. Everybody has had experience with concrete buildings. So I think I wanted to, I thought it was very important to touch on this first. So for concrete structures, there really is only one place to do it right, and that is underneath the floor. Okay? So if you remember everything that I said before, concrete buildings, because they have a lot of mass and because they have a lot of weight, they're going to be great for STC, for airborne noises, me talking, music, television, things like that. So an 8-inch concrete slab on its own is already code compliant. It's already going to perform around STC 55 on its own. That's why a lot of people say, hey, it's a concrete building. We don't even need to worry about impact. However, like I said before, if you leave your concrete slab unattended and actually install a floor directly over your slab, that's the worst thing you can do because an 8-inch concrete slab is going to perform around IIC 32. If you're adding a floor directly over the slab without any sort of decoupling or separation, you may increase by a couple points, but you're still going to be in the 30s, which is absolutely horrible in terms of sound comfort. Now, the only area that you can get creative, and this of course is if you don't have a suspended ceiling, which is 90% of the time. The only place that you can do it right is by using the right acoustic underlayment underneath the floor. And it's very important that you use the right product because there's an abundance of solutions out there. There's going to be corks, there's going to be foams, there's going to be textiles, there's going to be rubbers, and they're all going to react differently in terms of your frequencies that you're trying to control. Some products are great at controlling high frequencies, and some are great at controlling low frequency noises. So, what is the best product to control high frequency noises in concrete buildings? After 25 years of R&D, today we're able to say with 100% confidence that the best product to control high frequency noises in concrete buildings are thermoacoustic not woven synthetic fibers. This is a very long word just to say that textiles are going to react the best with high frequency noises. Why is that? If you have ever been in an older building, or if you remember going to a hotel maybe 10, 20 years ago, there used to be carpet everywhere. Yes, because it provided some level of comfort, but also because it was the absolute best floor covering to control impact noises. Okay? So basically, what we did was say, hey, why don't we take the same technology that carpet brings at controlling high frequency noises, but utilize that as an underlayment underneath your floors? Because today, not a lot of people want to have carpets everywhere. You want to have a nice ceramic tile, a nice porcelain stone, maybe a nice engineered hardwood floor or a nice laminate. And these are all becoming much, much more popular than carpets. So in order to maintain a good level of acoustics, you have to use a right product underneath, not only for acoustics, but also for a couple of other different reasons. Also, thermal properties, mechanical stability is very, very important. You're going to have wood, installed in some of these condos. Wood is going to expand, it's going to contract, and you're going to need something that is going to be able to hold that flooring from moving. Then you're going to have different elevations that are going to be needed, for those transitions. You want to work with something that has an environmental impact, something that is going to be greener. So we have acoustical membranes, textiles that are made from recycled synthetic fibers, and something that is going to be practical. easy to use. Whenever I'm talking to an installer, they are very worried about the weight of the product that they're using. There are underlayments out there that are going to weigh 120 pounds per roll. There are other types of underlayments that are going to weigh only 16 pounds per roll. So you can understand that that makes a huge difference in the productivity and the speed of execution in a site. Now, talking about light wood frame, one of the first questions that comes up is, can light wood frame be more efficient than concrete? And the answer to that is absolutely yes. It can definitely be more efficient than concrete. However, there is a lot more areas that you have to think about. And these are all the areas that I'm going to go through. First of all, you're going to have to think about your floor covering. Not everybody knows this, but we've done hundreds and hundreds of different tests to compare all the different types of floor coverings. Laminates, vinyls, engineered woods, tiles, and they're all going to behave differently. And even within the same type of floor, let's say two engineered hardwood floors, but from different manufacturers, because of their composition and their quality, they may also have a big difference in performance. So just know, for impact performance, you can see a difference by up to 5 points in comparison, comparing two different types of flooring. Now, the next step is going to be the acoustical membrane. Your acoustic membrane can influence your result by up to 7 points. Then you're going to have your wet topping. Now, if you remember, the wet topping is there for what? It's there for your airborne sound control because you're adding mass to your building. After that, you're going to have, or I hope you would have, some sort of a resilient material underneath that wet topping. That material can influence your result by up to 8 points, which is massive. It's very, very important to decouple that wet topping from the rest of your structure. And if you remember, the reason why we're separating all these materials is to control what? It's to control impact, footfall noise. That's where most of the complaints come in, specifically for wood frame construction. Oh my God, I can hear my upstairs neighbors, dropping things on the floor. I can hear them going up and down their stairs. Stairs, I've been talking to a lot of wood frame builders nowadays, and that seems to be the common thing is, oh my God, what do we do for our stairs? Well, what you have to do is decouple them properly in order to not have that vibration being transferred. I'm going off topic a little bit here, but next step is going to be the acoustic insulation. Now, whether it's bad insulation or blown insulation, we have never really seen enough data to really give us a sense of whether bad or blown insulation are very different or which one behaves better than the other. But the most important thing to remember is you have to fill that cavity up by at least 50%, because if you're not filling that cavity by at least 50%, you're going to create what we call a drum effect, which is amplifying all of your noises and is going to effectively decrease your STC as well as your IIC. So just remember, filling that cavity up at least 50% is crucial, and if you can do more, fantastic. Next step is going to be resilient channels or acoustical clips. Now, when it comes to resilient channels, it's not that it's a bad product. It's just that 9 times out of 10, it's not properly installed. Meaning that you're going to have guys that are going to install 2 layers of Type X drywall. They're going in, they're going fast, they're going through their screws, touching the joist and creating a lot of points of contact, effectively short-circuiting your entire system. All these screws are going to create a bridge for that vibration to travel. So you're effectively not neglecting, but completely defeating the purpose of a resilient channel by creating all those connections with the screws. So what do you do then? You use an acoustical clip that is going to make it dummy proof in a sense, to make sure that there's no screws that are going to touch the joist. Therefore, you're completely separating your structure from your ceiling, and it can increase your result by up to 7 points in impact performance. Last but not least, you're going to have your gypsum boards. It could be 1 or 2 layers of drywall. Now, if you have more layers of drywall, you're going to have more mass. And if you remember what I said before, the more mass you have, the better chances you are at getting a better STC performance. So if you did everything correctly, you can achieve results upwards of 60 STC and 60 IIC, which is considered luxury type ratings. Now, I've been talking about ratings since the beginning, and I think I just want to give you a little visual or an analogy so you can imagine these ratings in real life. So let's say we're in a room right now, and over you, there are three different scenarios. One that performs at a 50, ones that perform at a 55, and another one that performs at a 60. And I'm talking about impact, okay? If you're in a room that is performing at a 50 AIIC impact, you're literally going to be able to hear your upstairs neighbor walking from their room to the kitchen to the living room, and you're going to be able to trace exactly where they're walking to and from, which is not necessarily desirable, especially if you're in a higher end type building. Now, if you were to move 1 or 2 points more, let's say from a 50 to a 52, 1 to 2 points difference is not going to be noticeable by the human ear. So you're not really going to hear a difference. However, when we start getting into that 3 to 5 point difference, what we say is that your comfort level is going to be doubled. Okay. So if you were able to trace that person at a 50, let's say it performs now at a 55. You may be able to hear them going from one room to maybe another, but you're not going to be able to trace them on top of you. Now, if we're moving to a 50 from a 55 to then a 60, then you're not going to be able to hear that person over you at all, or very, very slightly, unless they're literally trying to make it a purpose for you to hear them, right? You're not going to be able to hear them otherwise. So 60 is really a high end luxury standard of a rating. So hopefully this gave you a little visual of what these ratings mean. So I am going to talk a little bit about the alternatives to wet toppings, and I'm hoping I'm not going to be running out of time here, but it's going well. So thank you for sticking with me. So I wanted to talk about the advantages of wet toppings and the importance of those. This is something that has become a really hot topic through the years because there's a lot of benefits from moving away from a wet topping to a dry topping solution, including this makes it a very environmentally friendly and sustainable solution. And it's going to be the most effective way to lower the amount of embodied carbon inside of your building by moving away from a wet topping to a dry topping solution. Also, the weight factor. You can literally be reducing your weight from 20 pounds per square foot when you're using a wet topping to about 5 pounds per square foot when you're utilizing a dry topping solution. Also, you're going to be able to meet impact as well as fire requirements with these types of systems. You're going to have a situation where you don't have to worry all that much about moisture and temperature control and curing time. Sequencing in a site can be done much better as well. And these products are going to be compatible with a lot of different type of floor systems. So let me talk to you a little bit about these types of systems. So first of all, here we have an example of a rubber felt hybrid technology where we're going to have these panels that are going to be 3x4s. They're completely floated. They are going to lay directly floated over your substrate. And obviously I'm talking about light wood frame construction here. As you can see on the video, these panels go down very easily. They're completely floated. They're butt jointed. So this type of product, along with an acoustical clip and 2 layers of drywall, is able to perform at an ASTC of 55 and AIIC of 55, which is amazing for a product that doesn't involve any sort of wet topping. Now, the next product I want to talk to you about is a recycled dry element, which literally is a combination of recycled paper, recycled gypsum, all in one panel with an acoustical material underneath. These panels are also floated. They're just fixed to each other. And What makes this product very special is that it's very versatile. You can use almost any type of flooring over it. You can do tile, you can do laminate, you can do vinyl, you can even do a hardwood floor that is nailed down so long as the nails don't go through the panel and touch the structure. So a product like this with a laminate floor as an example, with an acoustical clip can achieve also ASTC 55 and AIIC 55, which is really good ratings for a system that doesn't involve wet toppings at all. So allow me to give you here an example of 50, 55, and 60, but in a real life scenario. You remember what I was talking about before about somebody walking on top of you? So here we have a recording that I want to share with you. So if you have your headphones on, please now do the opposite. Turn the volume up because normally this is not going to be very high. You're just going to hear some footsteps. One assembly that performs at a 50, another one that performs at 55, and the last one that performs at 60. Hopefully you can spot the difference. So I'm going to play that in 1, 2, 3. Let's do it again. So there you go. This is a perfect example of how important it is to go from a 50 to a 55 to a 60, depending on what the expectations are for your project. So hopefully you were able to spot that. Okay, now talking about mass timber. Now I'm going to be blasting through a couple of these because we are heading to the end of our presentation. But I think mass timber is becoming a very interesting topic for a lot of builders, a lot of architects. So mass timber structures are gaining a lot of popularity, right? These are going to be very beautiful buildings. They're going to be able to construct, in a very fast manner, but they do have their challenges when it comes to acoustics. Mainly because they're significantly lighter, right? Because mass timber is so much lighter than concrete, it has a lot of issues with controlling sound. Now, one other thing that makes this very difficult is that 9 times out of 10, when you're working on a mass timber building, what you want is to have those ceilings exposed. And when you have those ceilings exposed, you're literally removing one area that we can play with in order to control acoustics. So all we're left with is the top portion of the project. So this is where we have to get creative, is on top of the CLT panel as an example, where decoupling is going to be extremely crucial. So let me just show you an example of how different mass timber is to concrete. So we did the test. We tested a 5-ply CLT and compared it to an 8-inch concrete slab. Okay, so we tested it for impact on its own, and a mass timber 5-ply CLT performed between 21 and 23 IIC. A bare 8-inch concrete slab performed between 28 to 32, which is better, maybe not drastically better, but it is better than mass timber. And then we tested airborne. It's airborne that you're going to see the biggest difference. A 5-ply CLT performed at around 39 ASTC on average, but an 8-inch concrete slab performed on average an ASTC of 55. So effectively, we're talking about 16 points difference, which is huge, a huge difference. And this is simply because concrete has a lot more weight and a lot more mass. Now, if you're working on a mass timber building that can allow for a suspended drop ceiling, fantastic. Then you have more chances of actually obtaining an ASTC of 60 and an AIIC of 60 as well. But let's remove the suspended ceiling for a minute and just think about the other ways that we can control 5-ply CLT with an exposed ceiling. Now, wet toppings are very popular still in mass timber construction. So if it is the case that you're working on a project that wants to use some sort of a wet topping, You're going to have your CLT panel. You're going to have a rubber type membrane underneath the panel, as well as an inch and a half, maybe concrete topping, then an underlayment and a finished laminate floor. And this is going to perform around ASTC 50 and AIIC 50, meaning that you can be code compliant with the right solutions with an exposed ceiling. However, if you want to move away from wet topping and go with something completely dry, we have our recycled dry element again here that we use completely floated on top of the system, exposed ceilings, recycled dried element, underlayment and flooring, and we were able to achieve IIC 50 plus and STC 50 plus, meaning that we're able to be code compliant with something that is completely dry, with a system, by the way, that is also able to respect fire code requirements. So basically, when you're over 8 stories, here in Canada at least, you need to comply with encapsulation requirements. Sometimes you need wet toppings for that, but we now have products that are able to comply with the Type X certification and the encapsulation requirements without it having to involve any wet toppings at all. If you're working on a project where you want to achieve higher results than building code, we have dry solutions that can get you to a higher rating. As an example, a lightweight acoustic panel combined with 2 layers of plywood, your finished floor can get you to a rating of 55 plus STC and 55 plus IIC. And we even have systems that are going to be getting you higher ratings than that. These are discrete isolators. As you can see in the picture, discrete isolators combined with mineral fiber, mineral wool, 2 layers of plywood, and your finished floor, we can get results in the 60s, STC 60, IIC 64 with exposed ceilings, which is absolutely fantastic results for mass timber. Now, we're going towards the end, guys, and I'm not going to spend a lot of time with our case studies because we are heading towards the end. I want to be respectful over your time. Just know that on our website, we have a lot of case studies that you can go to, take a look, and see what we have. We explain full stories of what the challenges were, what kind of solutions we utilized to tackle those issues, and what kind of performance we obtain at the end. We have some tests and some case studies with concrete buildings. We have some with light wood frame buildings, as well as some with mass timber structures. This is our latest addition, a mass timber structure that we're working on right now, which is the Academic Tower at the U of T here downtown Toronto. If you haven't visited the site, I think they're doing some tours, and if that's something of interest, I think Woodworks is organizing some sort of tour at this building. Absolutely fantastic. 14 stories, beautiful building, and we're very lucky that we're working on this project as well. Just know that we have a tool called Acoustics Index on our website. You can go, you can select the structure, select the type of materials that you want to evaluate, the floor type, and you can literally get results of different assemblies and get an idea of how those assemblies can perform. Here, it's a quick, QR code to all these resources, either to our website, to our Acoustics Index, to the sound experience, where you can hear a couple of those sounds that I made you hear today, as well as some information for our service for acoustic condo, meaning buildings that are already built. So very quickly, guys, why Acoustic? We're all about bringing you into the ecosystem of brands that we have. We are all about sharing the expertise that we've been able to gather in the 25 years that we've been working at this. We have all the data, we're very transparent, and we want to share that with you. And we do this all through a consultative and creative approach that is going to be customized for you. So if any of what I said makes sense to you guys, please make sure that you schedule a call with me or with anybody from our team of experts. We're more than happy to review the details and the drawings of your project, collaborate with you, collaborate with the acoustic consultant. We can provide full recommendations for your project. And our goal is really to make sure that you have a successful project. So I really, really want to thank you for your time. Because we're at the end of the presentation, I'm not going to be answering any questions here in the Q&A, but I'll make sure to answer those later on via email. And if you want my contact, please, here you can scan my code. This is my email. This is my phone number. That's our website. And I really want to thank you for sticking with me. And sorry for all the coughing. I think I was just too excited and was speaking too loud. But yeah, it was lovely to have you. And I would love to hear from you in the next couple days, couple weeks. And thanks again for your time. You have a great day.